Hey guys, today we'll be talking about infinite geometric series. So first of all, what is an infinite geometric series? Well, it's basically a list of numbers or like a group of numbers that keeps going on forever, and each number is multiplied by the same amount to get the next. So let's see. Here's an example of what this would look like. So say the first term is a to the 1, and the next would be a1 times r, because r would be the common ratio. The next would be a1 and then r squared, and the next with a1 r cubed, and this would go on forever. R is a common ratio, a1 is the first term. That's basically what an infinite geometric series is. But there's also different types. There's such as an arithmetic series, and there's just a regular geometric series. They're both all different types, but in this video we're just going over infinite geometric series. So first let's try this first example here. So find the sum of the infinite geometric series 5 plus, and that's supposed to be 5 over 2 plus 5 over 4. And then this goes on forever. Well, let's see. Let's write out this. Say we have the sum. Let's make the sum equal to s. So s is equal to 5 plus 5 over 2 plus 5 over 4. And we could see each time they multiply by 1/2. So 1/2 is the common ratio here. So the next term would be 5 over 8. And 5 over 16, and 5 over 32, and 5 over 64. And let's see, because this goes on forever and ever, what we're trying to do we're trying to cancel out some of the terms so that we have something we can actually add together. So one way we could do this is, let's multiply s by the common ratio. So s over here multiplied by 1/2, because that's our r. And so this is equal to 5 over 2 plus 5 over 4. And let's see if I could just copy and paste the rest to save us some time. Say there, yeah. I'll just do that. And move that down over here. So what we're trying to do is we're trying to remove some of the infinite going on forever terms, just to make this a lot easier for ourselves. So there we go. That's what we have, and then plus 5 over 8, and then also on for forever. One thing we can notice is now if we subtract these two equations, s minus s over 2 is equal to s over 2, and then 5 over 2 minus 5 over 2, 0, 0, 0, 0, and on for forever. So everything else cancels itself out. And we're left with 5 here. So s over 2 is equal to 5. Multiply by 2 on both sides, s is equal to 10. So that's how we know the sum is 10, because we set it as s in the original. Now let's continue to work on our second problem here. So find the sum of the infinite geometric series s minus s over 3 plus s over 9 minus ... so on forever. Well, let's see here. We're trying to find this, and let's write it out. 7 minus 7 over 3 plus 7 over 9 minus. And then we notice that we're multiplying by negative 1 over 3 each time, minus 7 over 27 plus 7 over 81. These questions can be tricky because you can notice that when you're multiplying, the sign changes. Just know that if the sign alternates, that just means you're multiplying by a negative common ratio, which is always alright. So one thing we can do here is we could use the formula for finding the sum. The formula is S is equal to a to the 1 minus 1 minus the common ratio. So A1 is basically the first term. So we know the first term here is 7. So the sum is equal to 7 over, and then the common ratio here is negative 1/3, because the first one is 7 times negative 1 over 3 is negative 7 over 3, and this satisfies so on. So it's 1 minus negative 1 over 3. So it's S over 1 over 1 plus 1/3, which we can convert to 4 over 3. And 7 divided by 4 over 3 is basically 7 times 3/4, which is 21 over 4, which is 5 and 1/4. So 5 and 1/4 is our answer for question number 2. Now let's work on the last question we have here, which is question number 3. An infinite geometric series has a sum of 10, and its first term is 4. Find the common ratio. Well, we could use our formula here, and we could try plugging what we know in. So if we know the sum is 10 and the first term is 4, we're trying to find what r is. This is not exactly an infinite geometric series, but we use the formula, so now we can just solve for r. Let's multiply by 1 minus r on both right side and left side. So 10, 1 minus r is equal to 4. 10 minus 10r is equal to 4. So 10r is equal to 14. And we can divide by 10 on both sides, so r is equal to 14 over 10, which we could also write as 1.4. So that's our answer for question number 3. So as we know, these are infinite geometric series, and there's a lot more to infinite geometric series, but this is just a brief introduction to how these work and some simple questions on infinite geometric series. We might make more videos on these types of series, and these infinite geometric series sometimes come up in the AMC10s and rarely, but still sometimes in the AMC8s. So it's a good thing to know. So that's it for this video. Thank you, bye.